Gravitation. First is universal gravitational law. Suppose you have any 2-point masses m1 and 2 separated by some distance r apart. So according to this universal law of gravitation state, every object in the universe which having some mass m will attract the other having mass m with a force or attractive force which is called gravitational force, and it will depend upon first product of mass of either body, and it will be inversely proportional to square of separation between them. So first is about universal gravitational law. Every object having mass attracts the other by a force called gravitational. It is directly proportional to the product of masses and inversely proportional to the square of their separation. Salman, is it clear?
Yes, sir.
So gravitational force F is directly proportional to m1, m2, and is also inversely proportional to square of separation between them. So if you combine these two terms, you will get F equals to, by removing this proportionality sign, by any constant capital G, m1, m2 by r square, where G is called universal gravitational constant, which is equals to 6.67 or 20 by 3 Newton meter square per kg square. You either use this decimal part or this fractional part for different calculation. Is it? Just write it down. You all have written?
Done, sir.
Salman?
Yes, sir, done.
Now, there is some property of this particular gravitational force. First is it is always attractive. Next is it will be medium independent. Which means if this entire system is immersed in a fluid or water, the gravitational force in between two particles will remain same. So it will be same either in vacuum or either placed in any other medium. Gravitational force will remain same. Next is it acts along line joining between their center. So it is also called central force. Hamza, any doubt?
No, sir.
Okay. Just write it down. Try to solve this part. You all have written this question. Hamza.
Yes, sir.
So what would be your answer? Khalid?
Yes, sir.
What will be your answer to this question? Just see, I've defined you above in this part. Gravitational force is medium independent. It means if you change the surrounding medium of the containing particle, then gravitational force will remain the same. So initially it was in vacuum for which gravitational force is F. Now it is immersed in water, so gravitational force will still remain same. So gravitational force in water will be remain same. Is it clear?
Yes, sir.
Iba, is it clear?
Yes, sir.
If two identical spheres having mass density as rho and radius r is placed touching each other, find the relation of force and separation. Suppose you have two identical spheres. This is first and this is second. Now they are placed side by side. So this is distance from this point to this point. So total separation between their center will be r plus r. So if you calculate gravitational force in between them, so force is equals to G, product of their masses, divide by square of their separation. So it will be G times m square divided by 4 times r square. Hamza, is it clear?
Yes, sir.
But in the question, you have given in terms of density rho. So we convert this particular mass in terms of density, as density is equals to mass divided by volume, and volume of sphere is 4 by 3 in pi r cube. So mass will be equals to 4 by 3 pi rho times r cube. Just put this value of mass in this part, you will get g m square. So it will be 16 pi square rho square r to the power 6 divided by 9 whole divided by 4r squared. Khalid, is it clear?
Yes, sir.
Now on simplifying, this 4 and 16 will cancel out in 4 times. We have r square in denominator and r to the power 6 in numerator. So on simplifying it, you will get 4 pi square rho square into g whole divided by 9 times r to the power 4. This whole term is constant. Force is equals to this much. Now, how is force related with r? Hiba?
So it is directly proportional.
R to the power 4. So it will be F proportional to R to the power 4. But we have learned above about gravitational force for any 2-point masses as they will be inversely proportional to R squared. Is it clear? So in the above part for point masses, in this part, we had force inversely proportional to R squared. This is only possible if masses are point and they will be separated at some distance r. But in this part, two spheres are placed side by side and I have calculated force in terms of density. That's why force is related with r like this. Is it clear?
Yes.
Yes, sir.
Okay. You all have written? Salman,
Yes, sir, done.
you all have written?
Yes, sir.
Okay. Let me define you one last question related to this. There will be a question. If body having mass m is split up and m minus m, and separated at d distance. Find relation between small n and capital N so that force is maximum. Let me define you how to solve this problem. In this part, we have a body initially having mass m. Suppose there is a body having mass m initially, split up into two parts, one having mass having mass m minus m, and separated at some distance d apart. Hamza, is it clear?
Yes, sir.
So we have to calculate force in between, as force between any 2 point masses separated by a distance d is g times product of masses, so m1, m2 by square of their separation d square. So on simplifying it, g over d square is constant. So if you multiply it, it will be m times small m minus of m square is equals to this f. Is it clear?
Yes, sir.
Now you'll be asked, is this force is constant or variable? So you'll say it will be variable and small m dependent, as small m is variable term. So we have to calculate value of small m with respect to capital M so that this force will be maximum. I defined you in calculus part for differentiation integration how to define maximum or minimum of a function. Khalid, do you have any idea how to get maxima or minima of a function? Hamza, I think your examination is going on. That's fine. Good. For function to be maximum or minimum, its differentiation should be equals to 0. Okay. So in this part, we have to find maximum value of force, which means the differentiation of force with respect to that variable part on which it is depending upon should be 0. So in this part, force is depending upon this small m, which is variable. So for maximum, df over dm should be equals to 0. Now let me differentiate it. So f equals to g over d times or d square m into m minus n squared. So if you differentiate it, df divided by dm, g over d square is constant, capital M is constant. So if you differentiate m, small m to the power 1, so it will be just 1. Differentiation of m squared, it will be just 2m, and equate it to 0. Hamza, is it clear?
Yes, sir.
Khalid, any doubt?
No, sir.
Now, since this coefficient will be a constant term, so this term must be equals to 0. So m minus 2m equals to 0. So small m will be equals to m by 2, which means if masses will be divided equally, then force in between them will be maximum. Eba, is it clear?
Yes, sir.
Okay, just write it down. Salman, any doubt?
No, sir.
You all have written?
Yes, sir. Yes, sir.
Any doubt till this part?
No, sir.
No, sir.
So let's stop here till this part. In next class, we'll start gravity and Kepler's law. Okay? Hamza, do you want to ask something?
No, sir.
Okay, good luck for you for examination.
Thank you, sir.
Okay then, Allah Hafiz.
Okay, thank you, sir. Allah Hafiz.
Thank you, sir. Allah Hafiz.